Hi, I'm an old guy and I do maths, and what we have in front of us today is a network on the left and in a few moments the resulting communication matrix on the right. Now let's have a look at the network. We have four vertices, A, B, C and D, and they are connected by these directional arrows which indicate the way in which communication takes place. So, for instance, C communicates with B, but B does not communicate with C directly. I should point out that we are dealing with a one-step communication matrix here. So the fact that B can communicate with C through D at the moment is irrelevant. That's a job for another video. Okay, so how do we illustrate this using a matrix? Well, we start in the top left corner and we see that A does not communicate with A. Otherwise, I'll just draw this in pencil, otherwise there would be a loop like that. I hope you can see that. I've just penciled that in very, very faintly. So that does not occur. So A communicates with D, it does not communicate with B, and it does not communicate directly with C. So it only communicates with D. So from A to A there is nothing, from A to B there is nothing, from A to C there is nothing, and from A to D there is 1. That's our first row. Second row, B to A, again nothing directly. B to B, again there is no loop here, so 0. B to C, no. Not directly, indirectly as I said, but that's not our concern in this video. And B to D, 1. Right, third row. C to A, no, not directly. C to B, yes, directly, 1. C to C, no. C to D, yes. So that's a no and a yes. Okay, you can see how this is building up. Last row, D to D, nothing. So D to D is nothing. We'll just go across this way for a change. D to C, yes, 1. D to B, no, not directly. And D to A, yes, this one here. So that is our one-step communication matrix and our network. Now, it's possible to take this matrix and draw this up. It may not look the same, but it will have the same effect. So let's try that. So just here, we'll go A, B, C, and D. Slightly different order, but just watch. A to A, nothing. A to B, nothing. A to C, nothing. A to D, 1. B to A, nothing. B to B, nothing. B to C, nothing. B to D, 1. C to A, nothing. C to B, 1. See how it's already looking different, but it will have exactly the same effect. C to B, 1. C to D, 1. D to A, 1. D to B, 0. D to C, 1. Let's see if we can squeeze that in there. And D to D, 0. So, just by moving this around a tiny bit, I've got a slightly different looking network. But let's just check out what we've got. Here we've got communication in both directions between A and D. Here we have it too. Here we have communication in both directions between D and C. Here we have it too. Here we have communication between B and D, B to D1. We also have communication from C to B. Here we have it too. So the network that you draw up from the matrix may not necessarily look like the answer that you get if you check the answers in your textbook if you're doing exercises. But as you can see, these two networks here work in exactly the same way and can be constructed from this single matrix. Okay, so that is it. This is a network and the communication matrix for it in terms of one-step communication. We'll look at two-step communication another time. Thank you for watching. I hope you found this useful. If you did, please like and subscribe, and I will see you next time. Bye.